Okay, I'm going to do parts 2 and 3 of question 6. I'll let you guys think about question 1, or part 1. So remember, to find the inverse, we just put the matrix, we augment it with the identity matrix. Okay, and we row reduce until the left side of the bar is the identity matrix, and then what is on the right-hand side is going to be the inverse matrix. So this is, first I'm going to subtract row 1 from row 2 and row 3. So this is 1, 2, 4, 1, 0, 0. 1 minus 1 is 0. Minus 1 minus 2 is minus 3. 1 minus 4 is minus 3. 0 minus 1 is minus 1. 1 minus 0 is 1. 0 minus 0 is 0. Now for the third row, 1 minus 1 is 0. 1 minus 2 is minus 1. 1 minus 2 is minus, 1 minus 4 is minus 3. 0 minus 1 is minus 1. 0 minus 0 is 0. 1 minus 0 is 1. Okay, and now I'm just going to clean up a little bit. I'm going to divide row 2 by minus 3. And when I do that, it's going to become 1, 1, 1/3 minus 1/3. 1, 1, 1/3 minus 1/3. 1, 1, 1/3 minus 1/3. Okay, and again, just without rewriting everything, just so I don't run out of room, I'm going to add row 2 to row 3. Okay, so minus 1 plus 1 is 0. Minus 3 plus 1 is minus 2. Minus 1 plus 1/3 is now minus 2/3. Um, 0 plus minus 1/3 is minus 1/3. And then 1 plus 0 is 0. Okay, and now what I'm going to do is divide row 3 by minus 2. So minus 2 divided by minus 2 is 1. Okay, minus 2/3 divided by minus 2 is now 1/3. Minus 1/6 divided by 2 is now minus 1/3 divided by minus 2 is now 1/6. Let me try to erase that minus sign. And then 1 divided by minus 2 is minus 1/2. Okay, now the next set of operations, I'm just going to have to come down here for part 3. I'm going to subtract row 1 from row 2. So the bottom row stays the same, 0, 0, 1, 1/3, 1/6, minus 1/2. Okay, 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. Okay, 1/3 minus 1/3 is 0. Minus 1/3 minus a sixth. Okay, minus 1/3 minus a sixth is now minus 1/2. And now 0 minus minus 1/2 makes that 1/2. Okay, and now I'm going to subtract 4 times row 3 from row 1. 1 minus 4 times 0 is 1. 2 minus 4 times 0 is 2. 4 minus 4 times 1 is 0. Okay, 1 minus 4/3 is minus 1/3. 0 minus 4/6, that's 0 minus 2/3, so that's minus 2/3. Okay, and now it's 0 minus 4 times minus 1/2. So that's 0 plus 2, so that's 2. Okay, and then the last operation is going to be to subtract 2 times row 2 from row 1. 1 minus 2 times 0 is 1. 2 minus 2 times 1 is 0. 0 minus 2 times 0 is 0. Minus 1/3 minus 2 times 0 is minus 1/3. Okay, minus 2/3 minus 2 times 1/2. So that's minus 2/3 plus 1, so that's 1/3. And now 2 minus 2 times 1/2, that's going to be 2 minus 1, which is 1. And then the second row is 0, 1, that stays the same, 0, 1, 0. 0, minus a half, 1/2, and then the bottom 0, 0, 1, 1/3, 1/6, minus 1/2. Okay, and then I should put the green thing there, and you probably can't see it, so let me scoot this up. There you go. I keep forgetting to do that. Okay, so now, just to give me some extra room, I'm going to say that M inverse, oh, that was interesting. M inverse, I'm going to factor out a 1/6, so it's 1/6. Okay, and so this is going to be minus 2, 2, 6. That's the top row. The middle row is going to be 0, 0, minus 3, 3. In the bottom row, it's going to be 2, 1, minus 3. So this is M inverse. Okay, now to use this to solve the given equation, we're just going to multiply M inverse by the vector 1, 2, 3. So this is 1/6 times minus 2, 2, 6, 0, minus 3, 3, 2, 1, minus 3. I'm going to multiply this by the vector 1, 2, 3. And what I get is 1/6 times, okay, so minus 2 plus 4, that's 2. So did I do that right? Minus 2 plus 4, that's 2, plus 18, that's 20. For the middle row, it's going to end up just being minus 6 plus 9, so that's 3. And then for the bottom row, it's going to be 2 plus 2, that's 4. 4 minus 9 is minus 5. Okay, so this should be L inverse of 1, 2, 3. And to check it, all we're going to do is just multiply the original matrix. We're going to multiply the original matrix by this vector that we got and see if it's equal to 1, 2, 3. That's a good way to check to see what we've done. So I'm going to do this in black. Okay. So now this is the matrix 1, 2, 4 times 1, minus 1, 1, 1, 1, 1, and we're going to multiply it by 1/6 times the 23 minus 5 vector. So I'm just going to put the 1/6 out here. Remember the associativity of the multiplication. So this is equal to 1/6. Okay, so now the top entry is going to be 20 plus 6. So that's 26 minus 20. So that's 6. So that checks out. Then the middle row is going to be 20 minus 3. So that's 20 minus 3. That's 17. 17 minus 5. 17 minus 5 is 12. Okay, so that's good. And then 20 plus 3, that's 23. 23 minus 5 is 18. Okay, and then of course, 6 divided by 6 is 1, 12 divided by 6 is 2, 18 divided by 6 is 3. And so this gives us pretty good confidence. Well, we definitely know we've found the inverse. We've definitely know that we've solved the equation LV is equal to 1, 2, 3, because we just checked it out. We just checked our work. And so we know that this vector here is the solution to the equation LV is equal to 1, 2, 3. And this gives us confidence that the way we computed our inverse is right. In other words, that we computed the inverse correctly.